Hi guys, and welcome to Chapter 15. Chapter 15 goes over non-renewable energy sources. Specifically, we'll spend the majority of the chapter going over different fossil fuels. However, toward the end of the chapter, we'll be going over specifically nuclear energy, how nuclear energy is harnessed, and specifically how nuclear energy is perhaps a slightly better alternative to fossil fuels. However, for the majority of this lecture will serve as an introduction to our energy needs, why we use energy, why we need energy, what sources of energy we primarily rely on, as well as some of the terms that we're going to hear over and over again in the following lectures throughout this chapter. So it's pretty safe to say that we use energy for a variety of different things. External sources of energy power our industry. It allows us to heat our homes and provide electricity to our houses. It allows us transportation, the ability to travel distant places very, very quickly in the form of cars, airplanes, trains, or any other source of transportation or locomotion, and much, much more. Energy is integrated into every step of our lives in the 21st century, and so having a consistent, stable source of energy is extremely important for modern day functioning. And not only do we need energy, but it's also really useful to see exactly where our energy is coming from. Now, we draw energy from a variety of different places, but the overwhelming majority of energy come from fossil fuels. About 80% of our energy sources come from coal, natural gas, or oil. Basically, these are going to be the non-renewable fossil fuels that we'll be talking about in a couple of later lectures. However, we are starting to grow our renewable energy economy. Biomass now constitutes around 5% of our energy consumption. Hydropower now is approaching 3%. Geothermal is still pretty low, but wind and solar constitute about 2.5% and 1.5% respectively. It's useful to note that we still have a long way to go. Again, 80% of our energy consumption relies heavily on fossil fuels, coal, oil, and natural gas. However, efforts are slowly being made to focus more on renewable sources of energy and decrease our CO2 emissions, as well as gain some semblance of energy independence. However, as I mentioned previously, 80% of our energy comes from fossil fuel sources, and when we add nuclear into the mix, nearly 90% of our energy comes from non-renewable resources. So it's going to be useful to understand what these non-renewable sources are, what fossil fuels are, and what nuclear energy is, what some of the benefits are to both of these sources, because there are benefits, that's why we're using them, as well as what all of the drawbacks are to these energy reserves. First and foremost, I think we should understand that energy and fossil fuels are not evenly distributed around the globe. Fossil fuels are formed under very specific geological conditions that we're going to go over in a little bit more detail in the fossil fuels lecture, which will be coming up next. These conditions in which fossil fuels are formed do not occur evenly around the entire world. In fact, pockets of fossil fuels are scattered across different countries, meaning that certain countries have enormous reserves of fossil fuels while other countries have none whatsoever. For example, half of the world's crude oil reserves are in the Middle East. However, it should be noted that Venezuela has the largest crude oil reserves of any single country. So while half of the world's oil reserves are in the Middle East, Venezuela has the most oil from any single country in the entire world, which is staggering. In addition to this, the largest supply of natural gas reserves is located in Iran, and the largest coal reserves are here in the United States with us. So again, note that because of the geologic conditions from which fossil fuels are formed, and because these geologic conditions do not occur ubiquitously across the planet, there are going to be pockets of fossil fuels in different countries scattered across the entire globe. Now, in addition to the distribution and availability of fossil fuel reserves around the world, it should be also noted that it takes energy to make energy. What that means is it takes energy to harness, extract, and deliver those fossil fuel reserves. So to do all of this, we must first exert some energy to actually get the fossil fuels in the first place. We have to find them, we have to dig them out of the ground, and we have to process them. And all of that takes energy, and in addition to this, all of that takes money. So the economics that are based on the energy that it takes to extract these fossil fuels are going to be very important when we begin to look at what fossil fuels are economically viable to extract and what are not. And in order to understand this, we need to understand a term known as net energy. Net energy is basically a term which expresses the difference between the energy return versus the energy spent. How much energy we spend to get the fossil fuels versus how much energy are in the fossil fuels that we are actually going to be acquiring. Now, in addition, when we discuss energy, so a term you're going to hear over and over again is something called EROI, which means energy returned on investment. Whereas net energy is the difference between returned energy and spent energy, EROI, or energy returned on investment, is the ratio of energy returned versus energy spent. If a fossil fuel has very high EROI, it means we're getting a lot of bang for our buck. For each unit of energy or each unit of money, because energy costs money, for each unit of energy or money that we put into getting that fossil fuel will deliver an enormous amount of energy back, meaning, again, we get a lot of bang for our buck. Now, on the right-hand side here, you get a graphic just depicting the energy returned on investment for a variety of different energy sources. And what I want you to pay attention to is a relatively low energy return on investment for renewable energy sources, with the exception of hydropower. Hydropower has an incredibly high energy return on investment. And then compare the relative rates of renewable energy return on investment to the energy returned on investment from non-renewable sources. Coal, natural gas, and in particular nuclear energy have incredibly high energy return on investment ratios. This means that it's economically viable to invest a lot of energy and a lot of money into extracting these forms of non-renewable energy because we're going to get so much back. We're going to get so much bang for our buck. Now, while fossil fuels are really beneficial in that they do have a relatively high energy return on investment, it should be noted that we will run out of them. Non-renewable fuels, be it fossil fuels, coal, oil, natural gas, or even nuclear energy, by definition are finite, and in fact all major fossil fuel reserves will be completely depleted within the next 300 years. Now, we're going to go over this in detail when we talk a little bit more about peak oil and some of the terminology in the fossil fuel lecture, but you should know that oil and natural gas only have about 50-55 years left maximum if we continue to use them at the rates that we have been for the last 10 years. Similarly, coal only has about 150 years left, again, if we continue to burn through coal, similar to how we've done in the last few years. But even before we totally run out, it will take more and more energy to extract and find the fossil fuel reserves that will be left as we continue to deplete them. So even before we completely run out, the energy return on investment ratios for coal, oil, and natural gas, as they get depleted and are increasingly hard to find, the energy return on investment will be so low that it will practically not even be worth extracting them, because it will take almost as much energy to find and process them as they will actually be able to give back to us. So to avoid this scenario where we're scraping the bottom of the barrel to find the last dwindling fossil fuels, we really need to look for more energetically and environmentally friendly forms of energy for future needs. Now, we're going to go over that in detail when we talk about renewable energy sources in Chapter 16, but for now, for the remainder of our fossil fuel and non-renewable energy sources chapter, we're going to be talking about fossil fuels and nuclear energy. Now, that is everything that we have for the introductory lecture into non-renewable resources. Next, we're going to dive into detail into what fossil fuels are, what the benefits of fossil fuels are, what they're used for, and what some of the drawbacks are as well. I'll see you then.